Separable differential order equations. An ordinary differential equation (ODE) is said to be separable if the ODE resembles its standard forms. What are these standard forms? They are of two forms. We have f of x dx plus g of y dy is equal to 0, and f of x dy plus g of y dx is equal to 0. So if you see any equation in these two forms, it means that that equation can be separated. So f of x, the first form, f of x dx plus g of y dy is equal to 0. So simply, you can separate it by taking everything that belongs to x in one side and taking everything that belongs to y to the other side. So I called I and I prime. So when I separated I, this is what I got. I took g of y dy over to the other side. So the minus comes in. Then also for f of x dy plus g of y dx. So to do this one, in case you might not understand what happened here. So to do that one, we have f of x dy plus g of y dx is equal to 0. So when you take this to the other side, we'll be having, okay, let's take f of x dy to the other side. So we'll be having g of y dx is equals to minus f of x dy. So we can decide to divide both sides by g of y. Divide both sides by g of y. So we will now have dx g of y over g of y is equals to minus f over x dy over g of y. So this cancels. We have dx is equals to minus f of x dy. So over g of y. So we can also further divide both sides by f of x. So divide both sides by f of x. So we'll be having dx over f of x is equals to minus the y over g of y. So it is actually what I got here. So in case you were not able to understand it, this is how it came about. So it means that separable equations, if you see an equation, an other differential equation in this form, just know that it can be separated to get the solution of the equation. Okay, here are some examples. Solve using separable method. Y prime is equals to 5y. So let's start from number 1. Solution. Y prime is equals to 5y. So remember that y prime, which is the first derivative, is also equals to the y over the x. So the y over the x is equals to 5y. So from the look of this, you can see that this can be separated. So let's separate the equation. We can cross multiply. The y is equals to 5y dx. Then divide both sides by y. So we'll be having the y over y equals to 5y dx over y. So we'll be having the y over y is equals to 5 dx. So in solving separable equations, when you get to this stage, the next thing to do is to integrate both sides. And this is also 1 over y, the y, integral 5 dx. So in integration, 1 over y with respect to y is ln y. And integral of 5 dx is 5x plus a. We added the constant while integrating the x part, the x variable. So don't forget, anytime you integrate, you always add the constant. And in this case, we're adding the constants to the x variable side. So to simplify this, we need to get rid of ln y. And to get rid of ln y, we can simply do it by taking the exponential of both sides. So that is exponential ln y is equals to exponential 5x plus a, because exponential of natural logarithm, that is ln, is equals to 1. So exponential ln y will give us y, and this is equals to e exponential 5x plus a. So depending on the question and the options, this can be your answer, or you can further simplify by saying y is equals to exponential 5x exponential a. Because if you remember the law of indices, when they are multiplying, when two powers are multiplying, they add. So we have y is equals to exponential 5x dot exponential a. Or you can further simplify by saying y is equals to exponential 5x b, or y is equals to b exponential 5x, where b is equals to exponential a. So this is an answer. This is also an answer. It depends on the option you see while solving the question. Number 2, x dx is equals to x squared minus 1 dy. So what we need to do is to separate it first. And we can see x dx, x squared minus 1 dy. So we need to divide both sides by x squared minus 1. So in doing that, we have x dx over x squared minus 1 is equals to the y. So the next thing is to take the integral of both sides. So we have integral of x dx over x squared minus 1 and equals to integral of the y. So I would like to solve this separately. Let's bring it out. X dx over x squared minus 1. So recall from integration, when we have something like this, if we differentiate the denominator, okay, so let's do it like this. Let u equals to x squared minus 1. Du over dx is equals to 2x. So let's make dx the subject of the formula. So we'll have dx is equals to, that will be 2x, and that will be, okay, let's go to multiply dx times 2x is equals to du, and divide both sides by 2x. So that will be du over 2x. So when you make dx out of the formula, we have du over 2x. So replace this dx back, we'll substitute dx back in the main integral. So we have x over x squared minus 1 dx. So this is now equals to x over, our x squared minus 1 is equal to u. So that is the u. Then our dx is now du over 2x. So we have du over 2x. So this can cancel. Sorry, x can cancel x. So we'll be left with integral of du over 2u. So it's now more simplified. So to continue, we can say this is equals to 1 over 2. We can bring out the constant, integral of 1 over u du. So we are simplifying it. Then finally, we can see 1 over 2. Integral of 1 over u is ln u. So, and recall that our u is equals to x squared minus 1. So finally, we have 1 over 2 ln x squared minus 1. So anytime you have an integral question like this, we can do it by substituting the differential of the denominator. So when you differentiate and it gives you a value that can cancel out what is in the numerator, so this is what you do. So I've gotten the answer for this. So let's put it back. So when I integrate this, I'll be getting 1 over 2 ln x squared minus 1. And remember, when you integrate the x side, you add the constant of integration, a. Then integral of the y, we have y. So we have y is equals to 1 over 2 ln x squared minus 1 plus a. You can decide to leave your answer like this, or we can multiply through by 2. We have 2y is equals to ln x squared minus 1 plus 2a. So this is the final answer. The last question, y prime is equals to y square x cube. So just as we have been doing before, y prime, which is also the y over the x, is equals to y square x cube. Okay, so this can be separated. So let's cross multiply. We have the y is equals to the x, y square x cube. So we can separate the y square, the y variable from the x by dividing both sides by y square. So when we have the y over y square, then we'll be left with the x cube. So integrating both sides, the y over y square is equals to integral of x cube dx. Okay, so this is also equal to 1 over y square, the y is equals to integral of x cube dx. So 1 over y square is equal to 1 y raised power minus 2, the y, which is equal to an integral of x cube. We have x raised power 4 over 4 plus a. So remember, anytime we integrate the x side, we add our constants of integration. So integral of y raised power minus 2, we have y raised power minus 1 over minus 1. This is equals to x raised power 4 over 4 plus a. So we'll be left with minus y raised power minus 1. This is equals to x raised power 4 over 4 plus a. So, okay, y anything raised power minus 1 is also equal to, because of the minus here, we have minus 1 over y. This makes an inverse 1 over y. This is equals to x is power 4 over 4 plus a. So when you add this over 1, we'll be having, so this is the factor, common factor. We're having x raised power 4 plus 4a. So we can take the inverse. We need to get y, not minus 1 over y. So we take the inverse of both sides. We have minus y is equals to 4 over x4 plus 4a. Then we can multiply both sides by minus 1. So if we multiply here by minus 1 and also here by minus 1, we'll be left with y is equals to 4 minus 4 over x4 plus 4a. So this is the final answer. So from what we've seen, we can say that anytime you're given an equation to solve a differential order equation, you need to first check if it is separable. And once it is separable, you go ahead and separate it, then you integrate both sides. When you integrate the x variables, you add the constant of integration, then we'll make y the subject of formula.